Hello, Lily. Thanks again for your understanding last night. I don't think in 14 years of doing that job that I've ever had to go home sick, and I apologize for doing that to you. I've got the questions that you have that you sent me last night on the screen here, and I'm going to go through them one by one. It may make more than one video because I like to try to keep them short. The YouTube doesn't like for them to get too long. It sometimes refuses to upload them. So if I stop halfway through, then I'll just make a second video for the last two questions. The first question that you sent me is a binomial probability question. And so the binomial probability, you can recognize them in a couple of ways. One is that you can find easily a P and a Q value. P is the probability that something will happen, and Q is the probability that it won't. And those two always add up to 1. And so if the probability that the car needs an oil change is 1 in 3, then the probability that it doesn't is 2 in 3. So that's one way that we recognize a binomial probability. Another way that we recognize it is that a lot of the questions are phrased in this way. One out of the next 4. So it gives you something that you can phrase in a choose question. So by that I mean, for part A, we're starting with 4 cars and we want to choose one of those cars to need an oil change. So we can write it in that form, or you may be writing choose in your class like this. I'm not sure, I haven't seen your class notes in a while from anybody in your course. So either way, that just means, both of those notations mean that we're trying to choose one out of the 4. And so with that, we also multiply the probability of a success, which is 1/3. That's the probability that we do need an oil change, and we want one car to have that probability. And the probability, oh, I'm sorry, it's not 1/3. Yes, it is 1/3. The probability of a failure is our Q, which is 2/3. 2/3 of the cars that come in are not going to need an oil change, and we want that to be the case for 3 out of the 4 cars. So that's where our exponents come from. So you can calculate on your calculator. You'll find a button that looks like this, and choose R, and you can put in the 4, choose 1 for that. And if you do, I believe you're going to get 4. And then you're going to multiply on your calculator using your A, B, C button. You can actually put in the fraction 1/3. It will look like that. If you hit 1, A, B, C, and then 3, it'll give you the fraction 1/3. And you're going to put that to the exponent 1, and then you're going to put in 2/3 to the exponent 3. And whatever answer you get, that's the probability of one of the cars needing an oil change, okay? So the same idea, and I won't have to go through all the steps, I'm sure, for the other two because they're very similar. For part B, it says 2 out of the next 8 cars. Now, I know that really breaks down to 1 out of 4, but we have to do it as 2 out of 8. And so, again, I'll just rewrite it in the choose form. This time, we want 1/3 to the 2. And then the rest of them will have a probability of 2/3 of not needing oil change. There should be 6 of those, okay? And then 10 out of the next 40. So again, it's just the same idea. 40, choose 10. And you want 1/3 probability for 10 of those cars, and 2/3 probability for 30, for the remaining 30 of those cars. So I hope that helps in terms of question 1, and I'm going to flip the page and go on to question 2, and I can see this is going to be a long video, so I will definitely split it up into 2 videos for you, okay? Alright, I've got question 2 here, and I'm just wondering if maybe I should make this into a separate video entirely, because we need to talk about the Z-curve and the Z-table in order to do a proper job of this, and I don't want to rush it. So what I'm going to do is I'll stop this video now so you can get started on question 1, and I will send you another video for question 2, and we'll keep going that way.